Hi, welcome to my video on solve a system of linear equations, three variables by elimination or substitution or a combination. And we'll call this part 2. Remember that you can pause the video and work these out, each one at a time, to see if you're right, and that way you see if you know or comprehend what you're doing. Solve the system. Notice we have three equations, and we got an x equals negative 2y, z equals a negative 6y, x plus y plus z is 7. So this is equation 1, equation 2, and equation 3. So the way I would handle this one is that I would sub negative 2 for x, and I do negative y for z, and I would sub those two into number 3. So number 3 is x plus y plus z equals 7. So negative 2y for x, and we'll go negative 6y for z, subbing those two in. Notice now that I have all y's, so when I add these up, I get, that's a 1, so negative 2 plus 1 is negative 1, and a negative 6 makes a negative 7y equals 7. Divide by negative 7, so y equals negative 1. So now that we have one variable, y is negative 1, if I put the y here, then I'll have x and z left. If I put the y into this equation, then I'll get the x. And if I put the y into this equation, I'll get the z. So what I'm going to do is sub negative 1 for y into number 1. So x equals negative 2y. X equals negative 2 times y is negative 1. So x is 2. And then I'm going to sub negative 1 for y into number 2. And z equals negative 6y. And y is negative 1. So z is 6. So we have x right here. We have z right here. So the solution is, if you wish to write it down as an ordered pair, x, y, and z. Or you can name it out. X is 2, y is negative 1, and z is 6. So again, each system that you get with three variables could be, they're not always all the same, so you got to be thinking. Again, I did substitution here. Number 2, I got three equations again. 1, 2, 3. So notice I have three variables, x, y, and I got a y, I got an x and a z, so I have three variables, three equations. But you notice that the second equation is already solved for y, so we have one answer. So if I can't sub y equals negative 2 into this equation, number 3, because there's no y. So, but if I sub y equals negative 2 into the first equation, putting negative 2 in here will give me the x. So I'm going to sub negative 2 for y into number 1. So let's write down number 1. And we sub for y. So 2x minus 2 equals 4. 2x equals 4 plus 2, because you move over, make it positive. 2x equals 6, divide by 2, x equals 3. Now that I have 3, I have y is already negative 2, x is 3, so I can't take the 3 if I put the 3 back in here, I'll only get what y is, so that's not good to do. But if I take the x and sub it in right here, then I'll get the z. So what I'm going to do is sub 3 4x into number 3. So 4x minus 3z equals 21. And we're subbing 3 for x. So putting 3 in the place of x by substitution, that gives us a 12 minus 3z equals 21. Negative 3z equals 21 minus 12. Negative 3z equals 21 minus 12 is 9. Divide by negative 3, and z equals negative 3. So I have a solution. We do an ordered pair. We got an x is 3, y already done, and z is negative 3 because it's an x, a y, and a z in that order. Or again, we can write it out. X is 3, y is negative 2, and z is negative 3. And that's 2 of these done. Hopefully, if you pause the video and work these out, hopefully you have the correct answer. Okay, let's continue. We have another one to do. Again, practice, pause the video, and work it out and press play after you get it done to see if you can do it right. Notice in this one we have an x, a y, and a z, 3 variables. And because we have 3 variables, we have 3 equations, number 1, 2, and 3. Notice the first one is already solved, so one answer is already done, 30, x is 30. I cannot put x in here because there's no x. So the only place I can substitute, I got to sub 30 into number 3. So sub 30 for x into number 3. So that gives us, let's do it right here, x plus y plus z equals 180. And so 30 for x, so we put 30 in the place of x. And when we do, we have, bring the 30 over, make it a minus. We got y plus z is 150. So now we got, we know that x is 30. We got 30 gone into place of x gives me y and z. But the second equation got a y and a z. So let's take these 2 equations and line them up. So we have 3y minus z equals 90. Let's call this equation 4, the new equation. So this is equation number 2. That's 2. This is equation 4. They're already lined up, and that we're ready to add them. So notice you got a y, you got a z, you got a number. Notice that the z's are automatically opposite each other, so don't have to multiply. So 4y equals, and if you add them up, you get 150 and 90 is 240. Divide by 4, and we get y equals 60. So we have x is 30 and y is 60. So we got 2 options. We got y is 60, so I can put 60 in right here and get what z is in this equation, or I can take the x is 30 and the y is 60 and put in right here. So I got 2 options. So if I sub, let's see, I have x is 30 for x and 60 for y into number 3, then I have x plus y plus z is 180, and x is 30, y is 60, and that adds up to 90 plus z is 180. So z is 180 minus the 90, So Z is 90. Or, if you wanted to, you could take the 60 and sub in here and work out Z, and you would still get Z to be 90. So it's your choice. But in the end, the solution is, again, we got the X is 30, we have the Y is 60, and we have the Z is 90. And again, we can write out 30, 60, 90. Remember, an ordered pair is X, Y, and then the Z in 3 variable. Now we have another one to do. Again, pause the video and work this one out. Just to show you, I have this one, number 4. I also have it on the next page. There it is there, number 5. And you might say, why do I have this one twice? Well, I'm going to do this one 2 different ways, because it depends on how your brain is working or what you perceive. So what I'm going to do here, I have A plus B is 11, B plus C is 17, and A plus C is 14. We got to work this, solve this. So notice the third equation has an A and a C. So this number 1, number 2, and number 3 to keep them straight. So if the third equation has A and C, so if I take equation 1 and I take equation 2 and I eliminate B, then I'll have a new equation with A and C. So I'm going to write, there's A, there's number 1, this is number 2. So I'm going to eliminate the B by multiplying by -1, by multiplying this by 1. Multiply by -1, I get a negative A minus B equals a negative 11. Multiply by 1, I get B plus C equals 17. By multiplying by -1, I'm eliminating my B now because B is in both equations. Even though they're not lined up, when I add, negative B and the B cancels. So I get a negative A plus C equals 17. So do I really need them above and below each other? No. Now I have a new equation called 4. But equation 3 got an A plus C is 14. Equation 4 got a negative A plus C is 17. And so we see if we made an error now. Got to be careful. 17, negative, and notice when I add this, again, one of those mistakes. Negative 11 and 17 is, again, see, that's part of my learning disability. So rub that out, and we make that a 6. So negative A, so that's a 6 right there. Okay, sorry about that. And notice that when I do put these below each other, the A's cancel. So 2C equals 20. That's a 6. Again, rub that out, make that a 6. Sorry, I added up. I don't know why I did that, but just a slip, one of those errors. So we divide by 2, so C is 10. So C is 10. Now I can sub C. I can sub C back into number 2 to get the B, and I can sub C back into number 3 to get the A. So I'm going to sub 10 for C into, I'm going to put it into number 2. And number 2 is B plus C equals 17. So C is 10, so B plus 10 equals 17. So B is 17 minus 10, B is 7. And also, I'm going to sub 10 for C into, I'm going to put it into number 3. Again, if you put 10 in here, you can see that A is going to become 4. So sub twice, so I write down number 3, A plus C is 14, and C is 10, so A plus 10 equals 14. A is equal to 14 minus 10, so A is 4. So we have an A, a B, and a C. So the solution, A is 4, B is 7, C is 10. Again, in terms of the letters like X, Y, and Z, this is A, B, and C. Or you can write out A is 4, B is 7, and C is 10. And if you want to check it back very quickly, what's A plus B? A plus B, 4 plus 7 is 11. What's B plus C? 7 plus 10, 17. What's A plus C? 4 plus 10, 14. So that's the correct answer. And I said that I have the same question twice, but in the previous one we did then, I did it by eliminating. But now I'm going to solve it by doing what we call partly by substitution. And here we go. So how am I going to do a substitution? Well, notice that, again, the last equation got an A and a C. So if I take this equation, this is a little strategy. It's also nice to know. If I solve this equation for A, I'll get A in terms of B. If I solve this equation for C, then I'll get C in terms of B. Both of these equations, A will be in terms of B, C will be in terms of B. So if I sub A in here in terms of B, sub C, placed it in terms of B, then this equation will have all B's and I'll get B as an answer. So that's another little strategy. So if you look around, we could also reverse it in that I can solve, this is A and B, I can solve this equation for C, I can solve this equation for, solve this equation for B and get B equals 17 minus C, A equals 14 minus C, and solve these two equations into this one and get what? The value of C. So either way it'll work. So what we'll do what we said before. We'll solve this equation for A. So we'll, okay, let's write down equation 1. So we'll solve number 1 for A. So let's write down number 1. So if we solve it for A, we'll get a negative B plus 11. And we're going to solve number 2 for C. Solve 2 for C. So number 2 is B plus C is 17. So we're going to solve it for C. So C equals negative B plus 17. So this is a new equation called 4, new equation called 5. So if I sub both of these into equation 3, so sub negative B plus 11 for A and negative B plus 17 for C into, we're going to put it, sub it into number 3. So A plus C plus 4, A plus C equals 14. So we said we're going to sub in for A, so negative B plus 11, and C is a negative B plus 17 equals 14. So by solving the first equation for A, we get it A in terms of B. We solve the second equation for C, C is in terms of B. So when we replace A and C here with all the B's, then we can solve this for B now, because B is the only variable. So negative 2B plus 28 equals 14. Negative 2B is 14 minus 28. Negative 2B is negative 14. Divide by negative 2, and we get B is 7. Now, if we got B is 7, I can put B back in the first equation, or the second one. So if I can't put B back in here because there's no B. So if I put B in here, I'll get A. If I put B in here, I'll get C. So sub, let me write, sub 7 4B into number 1. Write down number 1, A plus B is 11. So B is 7, so A plus 7 is 11. A is 11 minus 7, A is 4. So B is 7, A is 4. Now we can sub 7 4B into, if we need to get the C, so we're going to sub it into number 2. So number 2 is B plus C equals 17. B plus C is 17. B is 7. So 7 plus C is 17. C is 17 minus 7. C is 10. And same as the other one, number 4 we just did, we have the same answers done slightly different. So it's an A, a B, and a C. So A is 4, B is 7, C is 10. Or write it out. A is 4, B is 7, C is 10. And we got the same answers we did before, but we did 2 slightly different methods. So that's solving a system of 3 variables by elimination. We solve them by using substitution. You use whatever you wish to solve the question. Hopefully that was helpful. And if it is, then I hope you click the like button and the subscribe button and the notification button, because there's more videos coming. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. And that's the content that's on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.